Good morning. Today we're looking at section 3.5, which is one that you're going to need to be very hands-on with. I have a great tool for you listed here, and I've listed it as a link here in OneNote, but then I've also listed it as a link on our Canvas page. It is a place you can go in and play with these graphs, because what we're looking at here we're looking at the transformation of functions. We have looked at the different types of functions. So we've looked at even function or functions that have an even exponent. We've looked at functions that have an odd exponent. We've looked at absolute value. We've looked at root equations or radical equations. We've looked at step functions. Now what we're going to do is we're going to start to move those around a little bit. And so I've generated this activity for you where you can go in and play with it. I encourage you to use it perhaps on the practice. You will not be allowed to use this website on the test. So make sure that when you get into the certify and things like that, that you're able to use your own knowledge to figure out the transformations of these functions versus relying on the graph. But it's a great place to play with the graphs and start to understand what's happening there. So what I want to look at first is we're going to look at different kinds of transformations. There are several types of transformations that you need to be able to perform, and there's a certain order that they need to occur in. By transformations, I just mean that we're taking the original graph, what we're going to call the parent graph or the base graph, we're going to move it up, down, left, right, we're going to stretch it, we're going to shrink it, things like that. The first type of transformation that you need to deal with is a horizontal shift. So that means you're moving it right or left. The second type of translation that you're going to deal with is you're going to stretch or compress the graph itself. The third thing you want to do is you want to reflect it. And then the last shift you want to make is a vertical reflection. I'm sorry, a vertical shift. And this stuff kind of is related to order of operations. And so what we're going to look at is where these pieces of the translations occur. Our ultimate goal is we want to be able to get to a graph such as this. And we want to be able to take the parent function, and then we want to be able to shift and move where this graph's going to be. So the first thing I want to look at is I want to talk a little bit about horizontal shifts. So I'm going to move over to this activity called Desmos. Again, there's a link to it on our Canvas page for you. And I have listed a ton of graphs here. And the way you interact with this is you click on the actual button and that graph will show up. You click on it again to turn it off. So you can show multiple graphs at the same time. The first part I want to talk about is you need to be able to recognize the parent graph. The things to look for here are make sure you note that this first graph has an odd exponent. So we know that our hands are going to be going in opposite directions, and it's a positive value out front, so that right hand's going to be up. That generates our parent graph. And in your homework and on your test, you're going to be able to need to identify that parent graph. These horizontal shifts that we're talking about occur when something is inside the parentheses of that parent graph. So in this case, notice when we move to graph 2, we have put something inside that cube term. We've put a +2. Well, remember when we talked about the parabolas, the HK, we took the opposite value for that ordered pair. Here you're doing the same thing. So this +2 is going to shift it 2 units to the left. So that's the first thing you need to do is figure out right or left. In contrast, if you have something like this, the absolute value, again, your parent graph has that 0, 0 vertex that we're looking at. Notice in graph 4 here, we have something inside that parent graph, x minus 4. So picture in your head, left and right's kind of opposite. We're going to shift this right 4. Okay? So key parts, identify parent graph, then identify the shift. Now let's jump down to, so our first one, this horizontal shift, is what I call inside the function or inside the parent graph. Now we're going to jump down to the vertical shift because in my mind it just makes sense to show you that part next, and then we'll go back to stretching and compressing. Hopefully you remember what this rational function looks like in terms of a parent graph. Remember, it's going to have that asymptote at 0. The exponent of that x is 1, which is odd, so the hands are going to go in opposite directions, and the right side is going to be up because the value is positive. So this is our parent function. Now notice here, if we were inside the function, this +3 would be down below here as part of this fraction. But notice this +3 is what I call outside the function. That's where your vertical shift comes. And the vertical does just what it says. So notice here, this one moves up 3. So you look for that horizontal part is kind of the opposite. The vertical does what it says, up or down. Consider your third graph here, this cube root. Remember, our cube roots are kind of look like they're laying on their side. Our hands are going to be opposite because it's an odd root. So here's our parent graph. Notice the change as we move from number 7 to number 8 on the Desmos here is what I call outside the function, and it's a negative, so it's going to shift left 2. I'm sorry, down 2. Down 2 because it's outside the function. So let's go back to our notes here. And again, I'm going a little bit out of order here, but I think you'll see why in a minute. The vertical shift is outside the function, and this one was opposite. This one is the same. So come back now, take a second, and on your piece of paper, looking at graph number 9 here that I have, I want you to picture what the parent graph is going to look like first of all. It's going to be a square root, so it's even. You're only going to have what I would call half the graph. It's going to be laying on its side. Think about what the +4 is going to do. It's inside the function, so that's going to be a left to right. And then you've got your +1 outside the function, so that's up or down. The +4 is the opposite, so we go left. The +1 is outside, so we go up. So notice your original parent function would have been coming out of 0, 0, but this shifted it left 4 and up 1. So we've here combined the horizontal and the vertical shift. All right, so now let's look at some reflections. Notice here, our parent function here is a parabola. It was an even exponent, so the hands are going to go in the same direction, okay? There's no right or left shift. There's no up or down shift because there's nothing inside the function or outside the function. But when I add this negative, it's going to reflect the function through the x-axis. So if the function part, if inside the function we make x negative, then we are flipping the entire thing. Check out this one. We have the square root of x. There's our parent function. When we are inside the function, we go and flip the entire thing across the y-axis. So as far as x and y reflections occur, the way you can remember that is our reflections are going to be if you have f of x is equal to the negative of the entire function, we'll call the original function g of x, it reflects the x-axis. And if we have f of x equals g of negative x, notice the negative is inside the function, then it reflects the y-axis. So let's go back to our Desmos here, and you can play with those some. You can put any graph you want in here and see what happens inside and out. The last type of transformation that we need to look at is stretching and compressing. Remember our parent function here, square root of x. Notice when we jump down here to number 14, we are going to take that and we're going to divide the whole thing by 10. We compressed it, okay? We divided it by 10. In contrast, if you have something like the absolute value of x and you multiply it, we stretched it out. We made it get taller faster, is the way I look at it. We stretched it vertically. So now let's go back to our original one that I gave you over here. This one right here. So let's go in order. Our horizontal shift. I'm going to circle this in green. Horizontal shift is inside the function. So this is going to take it left 1. Stretch and compress, we'll circle that in pink. Stretch or compress, that's the part outside. Okay, this one's going to rise more quickly because we're multiplying by 2. So we're going to stretch it. Reflect, we'll circle that in, we'll go gold. Reflect is this negative, all right? And that's going to reflect it. And then the last one, we'll do our vertical shift, comes from out here. It's going to shift up 3. So let's do each one of those one at a time. So our parent function is right here. Okay, we've got our parent function there. We are going to do our, I'm losing my brain this morning. We're going to do our horizontal, I couldn't think of the word, horizontal shift first, which we said was our, as we referenced over here, was our +1, which was going to shift it left. So let's see if we're right about that. It did indeed shift it 1. The next thing we're going to do is we are going to stretch it out. Then we have to reflect it. And notice we reflected it through the x-axis. And then the last thing we're going to do is we're going to move it up 3. So let's go back to our parent function. Notice our parent function, we shifted left 1. We stretched it out. We reflected it. And then we moved it up 3. Break it down piece by piece when you're working with these. Again, I highly encourage you, use this Desmos when you are working on your homework. It's a separate link in your module on Canvas. It's also here on the OneNote page if you just want to click on it directly from here. I have all the functions we just did, but you can create your own separate graph, or you can just add new graphs to that one and play with the ones that you're doing from your homework. If you have any questions, please don't be hesitant to reach out to me. I'm glad to help you any way I can. Hope everybody's doing well, and I'll talk to you soon.